In these problems, we're going to make use of the multiplication principle, which says if there's a sequence of decisions to make, and maybe we could say n sub 1 ways to make the first decision, n sub 2 ways to make the second decision, n sub 3 ways to make the third decision, and so on, we just multiply all those numbers of ways together to get the total number of ways to make all the decisions. So this problem number 2 says how many different outfits can we choose consisting of a coat and a hat if we have 2 coats from which to choose and 3 hats from which to choose. The way I like to set these up is to write a slot for each decision I have to make. So what we have to do here is we have to choose coats and we have to choose hats. And then I'll just go in and say, here's the number of ways I can make each decision. We've got, for coats, I can make that any of 2 ways, for hats, any of 3 ways, and if I just multiply those together, we will get 6 possible outfits consisting of a coat and a hat. In problem number 4, what we're looking for are 2-letter words. So I'm thinking 2 letters, okay, well we're going to have a first letter and a second letter. And what we're looking for here is how many different 2-letter words, real or nonsense, can we make if the letters have to be distinct. So let's see how many ways we can make this first decision here. This is our first letter. I think we can choose any one of the 26 letters in the alphabet. And our second choice, now it says the letters have to be distinct. So whatever I use over here, I can't use here because the letters have to be distinct. So we have now 25 choices here. So we're going to have 26 times 25, which is 650 possible 2-letter words. These problems come out of section 5.4. We'll do maybe 5 of them, 2, 4, 5, maybe 6, 8, and 10. Problem number 2 says that how many outfits consisting of a coat and a hat can be chosen from 2 coats and 3 hats. So what we have is we have 2 coats and 3 hats, and what we want to do is get an outfit that is composed of a coat and a hat. I'll draw 2 slots for each decision that I have to make. So maybe we want to make a coat and a hat. So I'm just going to count the number of ways I can make each one of these decisions. I've got 2 coats, so we can write 2 for that, and times, because I'm going to make another decision. And we have 3 hats, so we're going to have 3 here. So all in all, there are 6 ways to make those decisions. Problem number 4 asks us how many 2-letter words, so we're going to have 2-letter words, so we've got 2 decisions to make. I'll draw a slot for each. How many 2-letter words can be formed using the letters of the alphabet when a repetition of letters is allowed? All right, so I have to make a first decision. I can put any one of 26 letters here, and because repetitions are allowed, I can put any one of 26 letters here. And multiplying those together, we will get 676 different 2-letter words. Now, problem 5 says that we have a railway with 20 stations, and if the names of the point of departure and destination are printed on each ticket, how many different kinds of tickets can be printed? So we've got 2 decisions here. We have point of departure and then destination. So we have the decisions we have to make then are this. How many points of departure are possible? Well, we could depart from any one of 20 departure points, but then what about destinations? Well, I'm going to see that as 19 because I'm just thinking we will not want to have a destination, the same place we departed. So if we multiply those, we get 380 different tickets that could be printed. Problem number 6 refers us back to problem number 5, but it says this. How many different kinds of tickets are needed if each ticket may be used in either direction between 2 stations? So in problem 5, we had 380 tickets altogether, but now I'm thinking this. If we can use a ticket in either direction, say we're going from point A to point B, we could go this way, or we could go this way. That's going to cut this number here in half, right? Because I have 380 going this way. Then I have if this way is the same as this way, then that's going to cut this one in half. So what I'm going to write here is this is just going to be 1/2 of 380, which is 190. And in problem number 8, we're asked how many license plates consisting of 2 letters. Let's get that. We're going to have 2 letters. There's our decision. We've got a letter and a letter, and then 4 digits. 1, 2, 3, 4. So how many of these are possible? So what we're going to have now are 2 letters. So we're going to have 26 possible choices for the first space, the 26 for the second. Those are our 2 letters. And then we've got our digits. So we're going to have 10 choices here, right? It starts, you could have a 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 10 choices there, 10 here, 10 here, and 10 here. So this is going to be 26 squared times 10,000. And this turns out to be 676 and 000. This many license plates are possible. Now, problem number 10 says, how many different ways can 4 books be arranged on a bookshelf? So just imagine yourself actually doing this. You've got a stack of 4 books, and you're going to put them on a bookshelf. So you're going to have one on the leftmost, then this one, and then a rightmost. And then you have to ask yourself, how many choices do you have for this book right here, for this position? Well, you got 4 books. You could put any one of them in that position. So we're going to have 4 choices here. And if you've already used one of the books, then you have only 3 books for which you can use that position. So this is going to be times 3, and then 2 books left times 1. That turns out to be 24 ways that we can do that.